Hello, everybody, and welcome back. Welcome back. We're still looking at our 2019 Euclid contest, and we're up to question number 7 now. Okay, so two parts, both of them written, so we need to explain what we're doing. A, determine all real numbers x for which 2 log base 2x minus 1 and is equal to 1 minus log base 2x plus 2. Okay, so I find log questions, they tend to be scary because they're sort of the last operation we tend to learn, and they look like functions, and functions are scary. And actually, if we look ahead at B, it's also sort of a function-based question. So these ones, they typically look hard. They actually aren't that hard as long as you remember the rules for logarithms. Okay? And even when you don't have logarithms, when you're just given a function, there's not a whole lot that you can do with it. So it's just, as long as you stick with it, you're patient, you slowly think it out, these sorts of questions aren't as bad as they ever really appear to be. So let's take a look at that first one. So we've got 2 log base 2x minus 1 is 1 minus log base 2x plus 2. Okay. So first thing I would do, probably bring the logs all over to the same side because there are rules for combining logarithms. Okay. And one of those rules says, oh, if you got a number out front, it can come in as an exponent. Okay. Just slowly showing our work here. And another one says, if you've got logarithms of the same base and they're being added together, that's equivalent to a single logarithm where the things inside are multiplied together. So you want to be very comfortable with these logarithm rules. Okay. Now we have a single logarithmic statement. And what's nice about log statements is you can always sort of trade them. They mean the exact same thing. They always have an equivalent, oops, not E, been doing too many calculus problems lately. They always have an equivalent exponential statement. We tend to be a bit more comfortable with exponent rules and how to work with them. So if you've got it down to a single logarithm, okay, you can sort of rearrange and have an equivalent. So I take my base 2 here. We have an equivalent logarithmic or exponential statement. And of course, 2 to the 1 is just 2. Okay? So now I just need to sort of solve this polynomial. When is this polynomial equal to 2? And we could expand out. Okay. And then we'll have x cubed minus 2x squared plus x. And is it minus? No, it's plus. So plus 2x squared minus 4x plus 2. And all that's equal to 2. The 2's on both sides cancel out. The minus 2x squareds cancel out. We're left with x cubed minus 3x. It's got to be equal to 0. Okay. I'll factor out an x. Okay. And then we can see with difference of squares, we'll have x minus root 3, and x plus root 3. Okay. And so those give me solutions of x is 0, x is root 3, and then x is minus root 3. Those are the only expressions I can plug in that make these factors equal to 0. Okay, so you'd say, there's my answer, all done, all squared away with quite nice, except when it comes to logs, just like you can't put a negative number under a square root sign, okay, you can't put negative numbers or 0 into logarithms. And if we go back and check our expression, this x minus 1 here is going to cause a problem. The other one's x plus 2, so it's not really going to be as much of a problem. But if I plug 0 in here, I've got log base 2 of negative 1. Well, that can't happen, so 0's out. And if I put negative root 3 in here, I'll have negative root 3 minus 1, and that'll be even worse. Root 3 is bigger than 1, so it's the only one that's going to work. Okay. And if you wanted to, you could double check that or grab your calculator if you want to, and you could work that out. I've got mine handy. I can just very quickly plug in and make sure I haven't screwed up. So square root minus 1, and then log base 2. It's a little easier when you have a calculator that actually will let you do logs with certain bases. Okay. But there's always a nice trick if you ever run into trouble, you want to compute log base 2 of something. It's always the same as log. There's always a log button on your calculator over log base 2. So this is the infamous change of base formula. Okay. And I do think oh, I screwed up my calculation. Oh, yeah. No, okay. So everything worked out. Calculators, all happy with that one. Anyways, we can move on because, I mean, hearing me press buttons in is almost as exciting as watching me press buttons. Let's just move on to the next question. Okay, so B part. We've got a function, f of x. It's a nice little quadratic, and it's equal to x squared minus 2x. Determine all real numbers x that satisfy this equation. F of f of x is equal to 3. Okay. So one thing you could probably try and do is say, okay, well, what's f of x? And so you get f of x in wherever the x's are in your expression. But we know what x is, or what f of x is. Okay. You can do this. I don't recommend it. I'm going to work it out just so you can see it in case you did try this, just to check your sort of your skills. Okay. 4x cubed plus 4x squared minus 2x squared minus 2x. X to the 4 minus 4x cubed plus 2x squared minus 2x. But that's just f of x. Now, if I wanted to do f of x, now I've got to plug in f of x wherever I see x. And then change those f of x's to x squared minus 2x. And it's going to be a bit of a pain now, so we're going to go this far. What am I going to do? I'm going to raise a quadratic to the power 4. This is going to have an x to the 8 in it. So we would do all that work. Just think ahead for a moment. Do all that work, and then what do we have to do? Set this equal to 3 and find the solutions. I don't know about you, but I don't have a way of solving off the top of my head random, oh gosh, I guess those would be called octic equations. And there's certainly no formula for this like the quadratic formula. So this is, I would say, not the best approach. I mean, I'm not even going to bother trying to expand all this out. I'm sure it's doable, and maybe there is a cleaner way of doing something. Well, let's see where another technique takes us, and if it's got an interesting answer, maybe I will come back and expand it out at the end. I mean, we've got time. Got as much time as I want. It's my video. But what's another way to approach this? Well, here's my idea. So we've got to do f of f. So whatever x is, f of x is some new number. So I might say something, especially because it's a written question, I might say something like let y equal f of x. And then let z be f at y. And so that's really f of x. Right? And so now we know f of z is f of x. I think I said of f enough times. Okay. So first, solve f of z equal to 3 for our possible z's. We're just going to work backwards. Okay? But now I'm just working with a single quadratic. Okay. Single quadratic, I use the quadratic formula, or I could try and factor this. Z minus 3 times z plus 1. Okay, so whatever x is, when I apply f twice, I'll either get 3 or I'll get minus 1. Okay? So now we can go back and try and solve for what y might be. because these were z, these are the values of z. Now I can find possible values of y, and then we'll do it again for possible values of x. Okay? Now f of y we already saw, so when this is equal to 3, it's the exact same as our last expression. So we'll either get y is 3 or y is negative 1. But what happens when f of y is negative 1? Well, you'll get y squared minus 2y is equal to negative 1. Y squared minus 2y plus 1 is 0. Factor that. We'll get y minus 1 squared. So y would have to be 1. So no matter what I pick x as, I'll either get 1, minus 1, or 3 for my value of y. And y, of course, is f of x. So now we just have to solve f of x for 3. We know how to do that. F of x for minus 1. We know how to do that. And f of x for 1. Okay, so x is 3, or it's minus 1. Solving f of x equals minus 1 is the same as solving f of y equals minus 1. They're just different variables. And so that would produce x has to be 1. Okay. And then solving f of x is 1. So that would be x squared minus 2x equals 1. X squared minus 2x minus 1 equals 0. Can't factor that easily. Just a quick check with the discriminant. B squared minus 4ac. So it looks like we'll have, we'll just quadratic formula this. It will work. So negative b plus or minus, it'll be a square root of 8. But it's a written question, so let's just briefly show our work. All over 2a, so it'll be 1 plus or minus, let's say 2 plus or minus square root of 8. Of course, 8 is 2 root, the square root of 8 is 2 root 2. So 1 plus or minus root 2. Okay? And unlike the logarithm ones, there aren't really any restrictions. Another thing you can do at the end, just to make sure all the math worked out, is randomly pick one of these and test it out. Okay, so 1 minus square root of 2, negative 0.4142. If I square that and subtract 2 times that, I get 1, and then 1 squared minus 2 times 1 is negative 1, and negative 1 squared minus 2 times negative 1 is really plus 2. You do get 3. So you just try them at random, but they do absolutely work. So those are the possible values. Okay, you don't have to worry about square rooting minus sign, square rooting negative things, or logging zeros or anything else like that. Okay, so yeah, it's not such a nice answer. If it had just been a couple integers, I would probably, there might be a nice way to sort of factor this. But with that, the 1 and the 1 plus root 2 and the 1 minus root 2, I'm not really inclined to think it's going to go well. What would be x squared minus 2x to the 4. Although one thing I can say, you can definitely factor out f of x here. And that would speed things up a little bit. Oh, what the heck, I'll try it out. If you're not interested in what the octic equation would be, feel free to look away. I'll see you guys in the next video for question number 8 and all the usual stuff I say. You know, feel free to throw a like on the video, that sort of jazz. Minus 4 plus 2 minus 2 plus 2 minus 2 plus 2 minus 2. Plus 2. There it is. Otherwise, that would have gone horribly. Okay, but if I can take out a factor of x squared minus x, doesn't that mean that x... Oh, because this has to be equal to 3, so I'm going to have to expand this in the end anyway. Oh, u. All right, x to the 6 minus 3, or 3 times 2, yeah. X to the 5 plus 12x to the 4 minus 8x cubed minus 4x to the 4 plus 4 times 4, so 16x to the 3 minus 16x squared plus 2x squared minus 4x minus 2 x to the 6 minus 6x to the 5, cancel those out, so we'll get plus 8x to the 4, cancel those out, so we'll get plus 8x cubed minus 14x squared minus 4x minus 2. You can really, really, really see that this would have been just a disaster. X to the 8 minus 6x to the 7 plus 8x to the 6 minus 14x to the 5. Oh, now it's minus 14x to the 4. It's plus 8. X to the 5. Minus x to the minus 4x to the 3 minus 2x squared. And then the same thing but a degree less and multiplied by negative 2. Plus 4x. Okay, and now at long last, we'll get 3 needs to be equal to this expression. So we'll say 0 is 8 x to the 8 minus 8x to the 7 plus 20x to the 6. Yeah, there's no way anyone's going to factor this. I think even knowing the answer, I'll somehow screw this up. Plus 4x, and then the minus 3 would come over. Okay? Yeah. I mean, trying to take out a factor of 3 here, or, I mean, I suppose you could realize 1 is a root. Pretty, well, you'd try 1, and then you'd realize, oh, 21 plus 24 is 45, 55, minus 30 is 25. Oh, even that didn't work. I'm sure I've screwed up a calculation in here somewhere. Yeah. Okay, so the message is octic equations bad. Okay? So go with the sort of step-by-step way we did it. Anyways, I've wasted enough time on this, enough of your time, enough of my time. Let's just move on to question number 8, but of course we're going to have to wait for that in the next video. So, thank you guys so much for watching. I'll see you for question 8 next time.